YouTube, welcome to Higher Math Solutions. This video tutorial will go over how to take derivatives using the chain rule. I wrote 3 functions down that you have probably seen already. And in these functions you would not use the chain rule, and you would only use the chain rule if they became a composite function. So if sine of x became sine of x squared, that would be a composite function needing the chain rule. Or perhaps it's sine of 3x. X squared plus 3, if you changed it to x squared plus 3 to the 5th power, this is now a composite function, meaning the chain rule would be needed. Or what if you started with the square root of x? If I were to change that to x plus x squared under the square root, this is now a composite function, meaning the chain rule would be needed. One of the hardest things to do with the chain rule and to know how to use it is when to recognize when you don't use it versus when you do. So let's go over the chain rule and do some examples. If I were to take the derivative of f of g of x, there are 2 steps. The first step is to take the derivative of the outside, but you leave the inside the same. And then you multiply it to the derivative of the inside. So let's start off with some basic examples. Let's start with the trig function, sine of 3x. What you want to think of it as is your g of x function is the inside, which would be considered the angle, which is 3x, and your f of x function is considered the outside function, which is sine. And when I follow the formula, I always take the derivative of the outside first, and the outside function is sine. So I'm going to take the derivative of sine, which is cosine. But according to the formula, you do nothing to the inside, so I just rewrite the inside function. Cosine of 3x represents the first part of the chain rule of taking the derivative of the outside. Now I'm going to multiply it to the derivative of the inside, which in this case is your angle. And the derivative of 3x is 3. I can go ahead and rewrite the 3 in the front. And 3 cosine 3x is the derivative of sine of 3x. Let's do another one. What if I have x squared plus 3 to the 5th power? In this case, the outside function is your power, and the inside function is whatever is inside the parentheses, which is x squared plus 3. So what I'm going to do first is I'm going to take the derivative of the outside first, which is the power. So I'm going to use the power rule. But do not put an x right here. What you do is you rewrite the inside. Remember, it's a composite function. So when I'm doing the power rule, which is bringing the 5 down and subtracting 1, what goes in here is not x. I am going to rewrite the inside. But all you do is the power, and you leave the inside the same. And now I'm going to multiply it to the derivative of the inside, which is this function right here, and the derivative of x squared plus 3 is 2x, using the power and constant rule. I can combine the 5 and the 2 to make 10, x in the front, and then this would represent the derivative of x squared plus 3 to the 5th power. Let's do one more of a basic chain rule. What if I have the square root of x minus x squared? First of all, you would need to rewrite this as a power. Can't have anything in radical form. And you need to recognize this as a composite. So I'm going to do the derivative of the outside first. And when you have functions like this, the outside is always going to be your power. So the derivative of the outside is using the power rule. But what I do to the inside, I just leave it alone. So all I did was the power part. And now I'm going to multiply it to the derivative of the inside, which will be 1 minus 2x. To make this look a little bit better, I can bring this down to a denominator because I have a negative power. So my final answer would be 1 minus 2x on the top over this 2 will be down, and then this would also be down as well because of the negative root. And that just makes it look a little bit cleaner. Okay. But what you can also do with the chain rule is you can also add the product and quotient rule with it. So we're going to do a couple of examples of those. So let's start with the product rule example. Here we have x squared times tangent of 3x squared. And what you need to realize is that this is originally a product. We have two functions. We have x squared as the first function. We have tangent of 3x squared as your second function. Now I'm going to start doing the product rule. So when I'm doing the product rule, I take the derivative of the first function first, and then multiply it to the second, plus the first function times the derivative of the second. But when you look at this function, you have to realize that that is a composite. So when you take the derivative of the second function, you will have to be applying the chain rule. So the derivative of the first function, which is tangent, will be secant squared, but again, remember, do not rewrite the inside or change the inside. And then times the derivative of the inside, which is 6x. You can clean this up a little bit by multiplying together terms on the outside, which is this term with this term. Do not multiply anything inside the secant squared, only terms on the outside. So I have 6x squared times x. And then this would represent the derivative using the product and the chain rule. So let's do an example of a quotient rule. So in this case, this is now a quotient function. So I'm going to start off using the quotient rule. So it's the derivative of the top function first times the denominator minus the numerator function times the derivative of the denominator. But when I'm taking the derivative of this, I need to recognize it as a composite and realize I need to use the chain rule. So this is x squared plus 3 to the 1/2. Remember, you always have to rewrite it as a power. And then I'm going to apply the chain rule. So you do the power first, but remember, do not change the inside. And now times it to the derivative of the inside. And then I put this all over the denominator squared. Now when I square a square root, they will cancel out, so I'll just be left with x squared plus 3. Now you're going to have to clean this up a little bit. I can, again, only terms on the outside get multiplied together. I'm going to go ahead and rewrite this square root as a power. 4 times 1/2 times 2 is 4, and x times x is x squared. From here, though, you're still not done. What you want to go ahead and do is do some factoring. So I can factor out a 4, and I can factor out an x squared plus 3. Now, which one you take out, you always want to take out the lowest power. So I'm going to take out the negative 1/2 because it's the lowest power. And then I'm going to do what's left over. I already have the 4 out. Now, to figure out what your new power is, you subtract. 1/2 minus a negative 1/2 is 2/2, which is equivalent to 1. And that should always be the case, where you get 1 left over. So I have an x squared plus 3 left over. And then minus this 4 was taken out, but I still have this x squared. And this whole negative 1/2 was taken out, so that's all that's left. We're almost done. What you're going to do now is you just have a little bit of cleaning up. This is a negative power, so I am going to bring it down to the denominator. And also you see these two terms will cancel. So what I have left over in the numerator is a 4 and a 3, which makes 12. And then when I bring this down, I will have a 1 plus a 1/2, which is 3/2. And so what's hard here is you have a lot of algebra work with this type of problem, and it will take you a few steps to get there, but your nice results will look really nice and clean. Now there's one more example I want to go over, which is how to use a double chain rule. And it's used with trig functions. So when a double chain rule occurs is when you have a trig function to a power and there's an angle. I always recommend to rewrite the angle inside, but move the power to the outside, and sometimes this helps people understand what to do first. Now in this case, this is a composite of 3 functions instead of just 2, but I still start with the outside and then work my way in. So I'm going to start with the power and bring it down, but remember, do not change the inside. Next thing I'm going to do is my next inside function, which is the trig. So now I'm going to change cotangent, which is a negative cosecant squared, but again, I'm not going to mess or change with the angle inside. And then your last step is to do the most inside function, which is the angle, and the derivative of 5x cubed is 15x squared. So this is considered a double chain rule because we had a power, a trig, and an angle. We all had to work outside towards inside. Some numbers can combine, but other than that, there's nothing else to do. And so that is how you use chain rule with composite functions. Thank you for watching Higher Math Solutions. See you next time.